Question number 33 is integrate 1 divided by 3 tan x 3 tan x plus 1 whole multiplied with cos square x dx. So this can also be written as secant square x dx divided by 3 tan x plus 1, because 1 divided by cos square x is secant square x. Now you put tan x is equal to t, because the derivative of tan x is given in the numerator, and from this dt is equal to secant square x dx. Put this value in your given integral. You have I is equal to, instead of secant square x dx you have dt, divide by 3, instead of tan x you have t plus 1. This is 3t plus 1 whole raised to the power minus 1, and since its derivative is the derivative in the base, that is 3t plus 1, its derivative is 3, therefore you have to multiply and divide by 3. So obviously this is equal to 1 divided by 3 natural log of 3t plus 1 plus constant of integration. So 1 by 3 natural log of the absolute value of 3. Instead of t we have tan x, 3 tan x plus 1 plus the constant of integration. So this is the answer. Very simple question it was. The next question is e raised to the power sin x cos x. This is also very simple basic question. E raised to the power sin x multiplied with cos x dx. You can see that the derivative of sin x is given, and therefore we can put t is equal to sin x, so that dt is equal to cos x dx. Therefore your integral becomes e raised to the power t, and instead of cos x dx we have dt. And from the table of integrals, the integral of e raised to the power t is e raised to the power t plus a constant of integration. So we have e raised to the power, instead of t we have sin x plus constant of integration. So this is the answer of your question. The next question, number 35, is square root 1 plus 3 cos square x its square root, and in the next it is sin 2x out of the square root. So we can see that the derivative of cos square x is given. How you can judge this? This can be judged by putting cos square x is equal to t, so that dt is equal to power rule of the derivative to cos x multiply with minus sin x. So this means that minus 2 times sin x cos x is equal to dt, that is minus sine 2x is equal to dt, or simply dt is equal to minus, here it should also be dx. So minus dt is equal to sine 2x dx. Put these simple values in your integral. You have I is equal to square root of 1 plus 3t multiplied with minus dt. Minus is taken out of the integral. The derivative of 1 plus 3t is 3. So we have to multiply and divide with 3. And we have 1 plus 3t multiplied with 3 dt. So now we can apply the power rule of the integrals, and we get 1 divided by 3t, 1 plus 3t whole raised to the power 1 by 2 plus 1, that is 3 by 2, divided by 3 divided by 2, plus a constant of integration. 3 gets cancelled, no sorry, it does not get cancelled. 2 gets onto the numerator, so we have minus 2 divided by 9, 1 plus 3t whole raised to the power 3 divided by 2 plus a constant of integration, minus 2 divided by 9, 1 plus 3, instead of t we have cos square x, plus constant of integration whole raised to the power 3 divided by 2. Let me check this answer. Yes, the answer is correct. Let me move to the next question. Question number 36, which is very similar to this. In this question, you have to integrate sine 2x dx divided by square root 1 plus cos square root 1 plus cos square x. So this is very simple question and very similar to the previous one. I think that you can do this by yourself, therefore this is your homework assignment. Question number 37. This is also too simple question. In this question you have to integrate 1 divided by 2 1 divided by 2 sine square x plus 3 cos square x dx. This question can be solved by multiplying and dividing by cos square x, or if you take cos square as common from the denominator, you get 2 sine square x divided by cos square x plus 3, and this is equal to secant square x, because 1 divided by cos square x is secant square x, and in the denominator we have 2 tan square x plus 3. So now we can see that the derivative of tan x is given in the numerator, therefore we can put t is equal to tan x, so that dt is equal to secant square x dx. Put it into the given integral. You have I is equal to, instead of secant square x dx you have dt, and divided by 2, instead of tan square x you have a t square plus 3, and we want to write the denominator in the form of t square plus a square, and for this you have to take 2 as common, and it is taken out of the integral, and you have in the denominator t square plus 3 by 2, that is the square of square root 3 by 2. Now since from the table of integrals we know that the integral of a square plus x square dx is 1 divided by a tan inverse x divided by a. We will apply this formula here. So we have 1 divided by a, that is 1 divided by square root 3 divided by square root 2, and this square root 2 can be written in the numerator, square root 2, and 1 divided by a tan inverse x divided by a. Since x is equal to t and a is equal to square root 3 divided by square root 2, and it is written in the numerator, plus the constant of integration 2 and square root 2, they get cancelled, and in the denominator you have 1 divided by square root 2 multiplied by square root 3, and this is equal to square root 6. Tan inverse square root 2, and instead of t we have tan x, square root 2 tan x plus divided by square root 3 plus the constant of integration. So this is your answer. Next question is question number 38, and in this question you have to integrate 1 divided by square root x secant square root x multiplied with tan square root x dx. This is also very simple question. To solve this question, make a substitution t is equal to square root x, and by taking its differential you have dt is equal to 1 by 2 square root x dx. Since square root x is equal to t, so dt is equal to 1 by 2t dx, and this implies that dx is equal to 2t dt, so that your given integral becomes I is equal to integral of 1 divided by square root x, that is 1 divided by t, multiplied by secant square x tan square x secant square root x is equal to tan, so secant t tan square root x, that is tan t, multiply with dx, and instead of dx you have 2t dt, and obviously this t gets cancelled with this t, 2 is taken out of the integral, and you are left with secant t tan t dt. From here you can see that how simple this integral is. We know that the derivative of secant x is secant x tan x, so its integral becomes, the integral of secant t tan t is simply secant t plus the constant of integration to secant t. Instead of t we have square root x, because t is equal to square root x is our substitution, plus the constant of integration. This was very simple and cute question. The second last question is question number 39. This is also very simple. In this question you have to integrate pi raised to the power sine x plus sine x raised to the power pi and cos x. You have to integrate it with respect to x, that its integral be I If you put sin x is equal to t, then obviously dt is equal to cos x dx, so that your problem becomes a simple problem. Pi raised to the power t plus t raised to the power pi, and instead of cos x dx you have simply dt. Separate the integrals. Pi raised to the power t dt plus t raised to the power pi dt. And from the table of integrals, a raised to the power x has the integral equal to a raised to the power x divided by natural log of a. So from this formula we have this the first integral equivalent to pi raised to the power t divided by ln of a, and instead of a we have pi, natural log of absolute value of pi. Since pi is positive, therefore there is no need to write the marks of the symbol of absolute value, so we can simply write ln pi. And similarly in the next integral, pi is since a constant, therefore we can apply the power rule of the integrals. T raised to the power pi plus 1 divided by pi plus 1. So pi raised to the power t, and t is equal to sin x divided by ln pi plus 1 divided by pi plus 1, t raised to the power pi plus 1, that is sin raised to the power pi plus 1 x plus the constant of integration. So hopefully this is your answer. Let me check it. The answer given in the textbook is pi raised to the power sin x divided by ln pi plus sin x whole raised to the power pi plus 1 divided by pi plus 1. So it is the correct answer. The last question is question number 40, and in this question you have to integrate cos x divided by 3 sin x plus 4 square root sin x dx. If you put t is equal to square root sin x and apply the differential, you have 1 divided by 2 square root sin x, and the derivative of sin x, that is cos x dx. So we have dt is equal to 1 divided by 2 square root sin x is equal to t, so this is 1 by 2t, and cos x dx. So from here we get that 2t dt is equal to cos x dx, and substitute these values in your given integral. You simply have I is equal to integral of cos x dx is replaced with 2t dt divided by 3 sin x. You can find out the value of sin x from here. If you square both of the sides, you get t square is equal to sin x. So you have 3t square plus 4 square root sin x, that is plus 4t. 2t dt divided by, take t as common between the terms in the denominator, sorry, 3t plus 4. T gets cancelled with t, and you have 3t plus 4 whole raised to the power minus 1. Since we know that the derivative of 3t plus 4 with respect to t is 3, therefore you have to divide by 3, and this is simply equal to 2 divided by 3 natural log of 3t plus 4. Apply the value of t. 2 divided by 3 natural log of 3, t is equal to square root sin x, 3 square root sin x, and plus 4 plus constant of integration. This is the answer. Let me check it. 2 divided by 3 ln 4 plus 3 square root sin x. Yes, this is your answer. In the next lecture, we will start the next exercise in which we will learn the integration by the method of substitution. So this was the last lecture on the integration by the method of substitution, and in the next lecture we will learn the integration by parts. We will learn the integration by parts from the next lecture. Thanks for watching.